Elimination reactions. Elimination reaction involves the loss of atoms or groups from a reactant molecule so as to transform saturated compounds to unsaturated compounds. Example of elimination: dehydration of alcohols and dehydrohalogenation of alkyl halides. When alcohols are treated with dehydrating agents like concentrated sulfuric acid, a molecule of water is eliminated and we get olefin. Similarly, when alkyl halides are treated with alcoholic KOH, a molecule of HCl is eliminated and we get an olefin, and this reaction is known as dehydrohalogenation. And depending on the reaction kinetics, elimination reactions can occur mostly by two mechanisms, namely E1 or E2. In E1 mechanism, which is also known as unimolecular elimination, it's a two-step mechanism. The first step involves the ionization of alkyl halide in presence of base, and that is the slow and rate determining step. Heterolytic fission takes place and we get a carbocation intermediate. So formation of carbocation intermediate is the first and slow rate determining step in E1 mechanism. The second step, in the fast step, base abstracts one of the beta hydrogen with respect to this carbocation. This carbon is beta, so base subtracts one of the beta hydrogen and the final product is an alkene. Usually, tertiary alkyl halides undergo elimination by E1 mechanism. For example, if you consider tertiary butyl bromide. When tertiary butyl bromide is treated with alcoholic KOH, the product formed is CH3, C, CH3, double bond CH2. That is 2-methyl propene. Let us write the mechanism of this reaction. So the first step is, in the first step, that is the slow step that involves the breaking of the CBr bond and we get a carbocation. And in this carbocation, and in the second step, so this is the first step, With respect to this bromine atom, this is the alpha carbon, and there are 3 beta carbon atoms. And in the second step, the base abstracts one of the beta hydrogen. So there are 3 beta carbons, and any of the beta hydrogen will be eliminated as a proton. So we can write so base abstracts one of the hydrogen as proton. We get so here that becomes double bond. So that is the product. That is 2-methyl propene. That is the final product. So E1 mechanism, it's a 2-step process. The first step involves the slow ionization of the alkyl halide to form carbocation. The second step, base abstracts one of the beta hydrogen to form the product. Same is the mechanism with dehydration. For example, if you take tertiary butyl alcohol and if you treat it with concentrated sulfuric acid, the product is again 2-methyl propene, and the step involved is same. And in E1 reaction, the rate is proportional to concentration of the reactant only. That is, rate of the reaction is proportional to concentration of alkyl halide in the case of dehydrohalogenation, and in dehydration rate is proportional to concentration of alcohol. And in the case of E1 mechanism, that involves a carbocation intermediate, and you know tertiary carbocation is more stable. So usually tertiary alkyl halides or tertiary alcohols undergo elimination by E1 mechanism. And in E1 mechanism that involves carbocation intermediate, there is the possibility of formation of rearranged products. So formation of rearranged product gives a hint that the mechanism is E1. For example, if you consider the elimination reaction of 3,3-dimethyl butane 2-ol on dehydration, along with the expected product, we get an unexpected product as the major product. So let us write the structure of 3,3-dimethyl butane 2-ol. So this is 3. So if you number the carbon atoms, this is 3,3-dimethyl butane 2-ol. And when this compound is heated with concentrated sulfuric acid, that is dehydration, you know, this is alpha carbon and this is beta carbon. And on this beta carbon, there is no hydrogen. So the expected product of dehydration is CH3. CH double bond CH2. This is the expected product. And this product is formed in minor quantity only. Reason is first step in this reaction, that is ionization of the alcohol, and we get a carbocation intermediate. So let us write the step. So in the slow step, that involves breakage of this bond, or H plus abstracts OH minus, and we get a carbocation intermediate. So this is the intermediate carbocation. And this is a secondary carbocation. And this carbocation can rearrange to a more stable tertiary carbocation. And this is by a 1,2 alkyl shift. So that the intermediate formed will be having this structure. And this is a tertiary carbocation. And a tertiary cation is more stable compared to a secondary cation. And from this, beta hydrogen can be abstracted by proton, and this is beta hydrogen. This is also beta hydrogen. When it is eliminated as a proton, we get the this beta hydrogen will be eliminated, because that leads to the more stable olefin, and its structure is CH3, C, CH3, double bond, C, CH3, CH3. So the secondary carbocation rearranges to a more stable tertiary carbocation, and when this hydrogen is eliminated as a proton, the base subtracts proton, and we get this product. And this is the major product, and that is 2,3-dimethyl 2-butene. And this is the major product. Now coming to E2 mechanism. It's a bimolecular mechanism. That's a one-step